Okay, physics fans, welcome back. And here's a take a look at the Moodle as it stands today. And there's a quiz down here, force review quiz, that only a few people have gotten down to. There's a worksheet here that has some questions that I had tried to ask you to do. And if you're having any issues with them, the answers are here, the solutions are here. And it's not normally how many I ask. I usually assign all 47 questions that are in this little booklet, in this worksheet. But I'm doing about, 12? So about 25%. So try them. If you have any questions, just email me and then I'll make a work. But I'm not going to put up a video if you can get them. I'm going to do this review quiz for you. So here is my version of the quiz. Each version will have different numbers and stuff like that. So it's the same question over and over and over, except for it says determine the acceleration. Here it says the net force, the frictional force, and the push force. So a 0.68 kilogram remote control car accelerates from rest to a speed of 5.1 meters per second in 20.5 seconds. There is a coefficient of friction of 0.17. Okay, so let's start working on this. Okay, so let's draw a free body diagram. So on a surface, there's a normal, and there's a force of gravity. The push force is this way, and the frictional force is this way. Okay, and it is accelerating this way, it is traveling this way. So we can start off with Newton's second law. F is equal to F net equals ma. So we have the initial speed, vi, we have vf, and we have t. So we can use actually kinematics to get this time. That acceleration. The acceleration is going to be the change in velocity over time, and that change in velocity is 5.1 meters per second divided by the time of 20.5 seconds. Okay, so let's just go 5.1 divided by, I've got to do something about this calculator, divided by 20.5. And that's 0.2488. And that's in meters per second squared. And that would be, if you need to put a direction, you'd go forward. Because there's nothing here stating direction. Okay. And that's the acceleration. That's what we put in. What is the net force then? F net is equal to ma. And the mass is 0.68 kg times the acceleration that we just got. So we take this and multiply it. So times 0.68, and we get 0.1692. The unit for that is newtons. Now that's the net force. What is the frictional force? Well, the frictional force is mu mg. It's not telling us whether it's static friction or kinetic friction, and we're just given that. So you just use that. And I believe it's actually going to be a rolling friction. The tires would be rolling. But maybe it's also an air friction. Maybe it's all of them together. 0.68 kg. And on the Earth, it's 9.8 newtons per kilogram. So we'll pull this up. And we'll go 0.17 times 0.68. Did I not do times? There we go. Times is kind of... I'm going to have to redo something on that calculator. 0.68 times 9.8. The decimal doesn't like working. Now it's working like stink. Here we go. Ooh. I'm going to have to return this calculator. JK. 1.133. Or 13288. 29. So, which one is winning? This one is winning. Which one is losing? This one. So it'll be F push minus force of friction is equal to F net. That's Newton's second law. So the push force is what we're trying to find out on the last question. Minus this frictional force, 1.1329 newtons, is equal to 0.1692 newtons. So we can get F push is equal to those two numbers together, and just did that on the calculator. It'll be 1.302. 0.302 newtons. I'm going to put 4 sig figs in here. Okay. So those are our answers that we're going to plug in. Back to the website, I've plugged those numbers in, and let's finish that attempt. Answers are all saved. Submit it all. Yes. Yay. And now this is just telling plus or minus, so I'm doing roughly 1%. That number was the answer. Ooh. Oh, did I type it in? Yeah, I did type it in wrong, but hey, within 1%, it was still correct. And that. And that. Yay. 1.1682 at 1 point. Ooh, I skimmed out of there. Anyways, that's how you do that one. And it's kind of like you're pushing, but friction doesn't push back with all of the same amount, so you're going to be accelerating because you have a net force. And that net force is 63. So the net force divided by the mass, F equals ma, so A will be F over m, so the acceleration will be 0.63. And your time's going to go up. And we'll see this go. and it's accelerating. Now, not extremely fast, but it's good. We can also see that the water in this is slanted. It's a little bit more there. If I increase the force, you see the slant of the water is more because the net force is bigger, and it's the net force. So water in a glass is good accelerometer. And if I stop pushing as much, only push with 51, so now the net force is backwards. I'm slowing down. You can see the frictional force pushing back is kind of telling you which direction the net force is. And let's get it going fast again. Huge thing, and I'm going to push against it, and both friction and I will try to slow it down. Now it's really slanted because the net force, and now it's going backwards. Anyways, there you go. Thank you very much for paying attention. Here's the jingle.